Cek, cek, cek. Cek, cek, cek. Oke, kita akan membuat enggak sih membuat apa namanya, nyoba belajar lah pakai sketch. Aku nggak tahu caranya pakai sketch.
Green.
Tu pelo.
Sick, right? ¿Te gusta?
Hello, fellow Scratchers. Paper Minecraft, Scratch Snapped, Epic Ninja, Geometry Dash, and Apple. What have these all got in common, apart from being Scratch games made by me? Give up? Well, they are all tile-based scrolling games. That is, games that have their levels constructed from a regular grid of tile sprites. Creating levels in this manner has been an extremely common technique in video game creation for decades, and one that I myself have used over and over again. With the aid of this video, we are going to be building together the basis for such a game engine. What is exciting about this technique is that it is not only good at speeding up your projects, but it makes challenges like having off-screen enemies far easier to manage, as well as many other tricky things like built-in level designers and level saving systems. You are, of course, absolutely free to create all your own custom sprites for this project, but if you want a quick start, take a look at the notes under this video for a link to a starter project. You'll find it already set up with a number of pre-configured sprite costumes from a familiar Mario game. Simply remix it, and off we go. So, if you remixed my starter project, you'll have 3 sprites. The first, named Mario, contains a simple Mario sprite which is hidden for the time being. The middle sprite is called Tiles. If we look at its costumes, you'll see the first 2 are quite interesting. One named Big, containing a large square. The purpose of this I shall explain later. The second is a blank costume, useful for the blank areas of your level. All the rest of the costumes are cool level tiles. And if you look at their size, they are all 16 by 16 pixels. If you draw your own, then make sure to keep to this size too to follow on for this tutorial. If we look closely at one of these costumes, you'll see how it is precisely lined up with Scratch's checkerboard grid. It's super useful to know that the squares in this grid are exactly 4 by 4 pixels in size. So if our costume lines up with this, then we are all good. Also, the costumes are perfectly centered in the costume editor. A tip for checking this is to press Ctrl-A to select the costume, and then drag it. It will snap back to the center by itself, showing that it is already in the right place. If you design your own costumes, just make sure they are aligned and sized just like this. Okay, let's talk about creating our tile grid. I'll select the block gold costume because it's nicely outlined shape. Now click onto the coding tab. Notice how small our 16 by 16 sprite looks on the stage. We're going to double its size. Add a when flag clicked block, and under that set size to 200. For good measure, add in a go to position XY 0, 0. Now run the project so our tiles become 32 by 32 pixels instead of the old 16 by 16. Pull out a create clone of myself block into some free space and attach it to a new change Y position by 32 block. Now this is cool. Click the clone and move block script and notice how a new clone of the tile is created, while our original sprite skips up to perfectly sit above it. Right, smash that script a few more times with your mouse and we can generate a very handsome looking column indeed. Right, we can easily automate the process of cloning a whole column of tiles. Hit the green flag button to reset our project, and then add a new repeat block around the create clone and change Y position blocks. set it to repeat 5 times and click the script to run it. Perfect. Told you that would be easy. But hold on one moment. Were you expecting 6 tiles in our column? After all, we asked for a 5, didn't we? Don't worry about this. It's not a bug. Remember, when our project starts, we already have 1 tile on stage, so after creating 5 more clones, we do indeed expect there to be 6 sprites in total. So let's move on. We can improve our code by replacing the number 5 with a new variable. Create a new one named clone count y, leaving it set to for all sprites, and set it to 5 under the green flag, and drag the variable into the repeat loop, replacing the number 5. Now is a good time to click the green flag again to make sure that the variable gets set before we do any more testing. Now click our repeat loop to ensure it draws our column still. Now, wouldn't it be nice to move this little column further down the screen, perhaps so that it was centered? We just introduce set y position block from the motion category before our repeat loop and set it to clone count y multiplied by -16.
If you're still typing your coding prompts, you're leaving performance on the table. You're prompting cursor over 100 times a day, but typing detailed context takes forever. So you send lazy.
Why -16? Well, 16 is half of 32, it's half a tile, and minus means backwards. So we're moving backwards by half a tile for every tile that we want to draw, which is half the whole stack. Click the code to test it. Good work. So we have a column of tiles. How do we make this into an awesome grid? Well, obviously we need to move a tile to the right to begin the next column. So stick a change x by 32 at the end of our script. Now when we run this script, you'll notice the extra sprite at the top has hopped to the right.